Hello, this is Matthew Harding for SIT 315. Today we'll be looking at some useful built-in tools that will help you with parallelization. So we'll be looking at JThreads, concurrent unordered maps, the theory and implementation of them both. So first starting with JThreads, so they were added in C++ version 2020. They're accessed in the normal thread header. They've got all the normal features of standard thread with two key differences. The first is that threads will automatically rejoin themselves when they're with the main thread when they're destroyed, and that the threads can be aborted with a stop token. These are very helpful functions, and let's see them in action. So we've got a simple program here to demonstrate JThreads and the ability to abort the threads with stop tokens. Firstly though, make sure that you check your project's properties and set the language standard here to at least C++ 20. It normally defaults to 14, but you've got to be at least 20 for JThreads to exist. Once you've done that, so we make a stop source here, make two JThreads, we pass the thread function here and the stop source.getToken. This then starts this thread function working, which is a infinite loop that only stops if the stop token gets this stop requested here. Main thread sleeps for 3 seconds just to simulate some work happening. Then we request the stop. Now this then stops both the threads because they're both working off the same stop source. And you notice that there's no join here, and it just finishes. And normally this wouldn't work with threads or p threads, but let's see how it works now. So threads are running, the main thread finishes, and the other two JThreads finished as well, and it all works. There's no crashing. So that's one of the main benefits of JThreads there, being able to stop them and not needing to join them. So this program demonstrates another use case for JThreads and stop tokens. So we've got a independent function here which does work and finishes, and then we've got a dependent function here which does a infinite loop until a stop is requested. So we set them up with two threads here. We use a traditional join for the independent thread, and then when it joins we then send the stop token to the dependent thread. So in this case the dependent, the JThread that's got dependent thread function is the only one that's getting the stop token. And let's see what happens. So it's all running and it stops and everything finishes. So this is just another use case for JThreads and stop tokens. And this is in fact how I solved the producer-consumer problem in Parallel, by having the independent threads act as the producers and the dependent threads as the consumers. So it's very handy and very useful. So moving on to concurrent unordered map. As the name suggests, it's a concurrency safe container. It's got similar functions to standard map. However, the pairs are not ordered by key, hence unordered. It achieves the parallel access with buckets. So what's a bucket? Well, basically a concurrent ordered map is actually a map of maps, and each submap is known as a bucket. The bucket size is fixed and it can be set with the function max load factor. So any operations that access the same bucket are blocking, and there's going to be some mutex behind the scenes doing that. But operations between different buckets, separate buckets, are non-blocking. So bucket size is important and has to be considered. So take this for example. So we've got a map with 10 elements and a load factor of 5. We'll end up with 2 buckets, which means that at most 2 threads can access the map at any one time. So if we had more than 2 threads, and if that's going to be a problem, we could do a load factor of 2. Now we've got 5 buckets. At the same time, you don't want to overdo the buckets, so otherwise it just becomes inefficient. So it's important. You have to consider how many elements are going to be in the map and how many threads are going to be accessing it. So the methods for concurrent unordered map, there's concurrent safe ones and non-concurrent safe ones. The concurrent safe ones are really most of the ones you want to use, like at, insert, the square bracket operator, find, count, size. These are all the main ones. You got some other ones here like clear, that clears the whole map, swaps two maps, equals, sets another map to a map, and then there's an erase and then a max bucket size. So these ones are not going to use very often. So really most of it is concurrent safe. So you don't have to worry too much about using it unless you're using these extra functions here. So let's see how it works in practice. So here we've got a simple program to demonstrate concurrent unordered map. So first off, make sure you include the header here. So we make the map here, so we're going to use integer key and string value. We're going to set the load factor to 10 in this case. So you can see here we can use the square brackets to insert a new element. We can also use the insert here. It returns another pair, and the second of that pair is a boolean, which returns true if the insertion was successful, otherwise failed. You can do find, you can use the map end there. Let's make some threads here, jthreads. We're going to send a reference to the map to each of them, and what they're going to do is they're going to search the map for a key. We're going to go from 0 to 1000 in this case. If it's not found, then we're going to insert that value. So they're going to double up on each other at times, well, a lot, and the idea is that the map should be able to handle that without any blocking or mutex is needed in our case, and then we're just going to join them and we'll see what happens. So let's have a look. So it was printed out all the values here. Now importantly, see how they're not ordered at all? Well, that comes with the name, unordered, so that's what you get. However, there is 1000 of them, so it's got that right. And it means, and as you can tell, there was no crashing, so it handled the two threads operating on it at the same time fine. And that's really how it works. So pretty simple and very easy to use. Of course, you could make your own version of this with the map of maps, but this is a lot simpler and it just works, so that is handy. Alright, so that concludes today's presentation. Hope you found it informative. So it's good to know that there are some very robust and valuable tools in just the regular standard C++ library, and they're definitely worth using. They work very well, and you can stay up to date by using the cutting edge JThread instead of the old-fashioned thread or pthread. That's old news. But anyway, good luck with the rest of the trimester of what it is, and thanks very much. Bye.